CD8 cluster of differentiation.
Nakagod lang. Makabot ka, naradyas na ito.
Lagyan na siya kay mic na lang siya.
So, need po ito.
Hingip sa buhay. Good morning, class.
Morning, sir.
Good morning, sir.
Huwag pang mata si Normandy. Si Antingog. Morning, Nor.
Morning, sir.
Yeah.
Yeah.
Ha?
Yeah, online ulag.
Karon. May gani kay kusog-kusog na gamay ba?
Ang saan yung wala?
Douglas, maklaro na ang screen. Okay. Okay, let's start to. We'll make it fast because this is a long topic. Do I... Sorry. Okay, good morning, class. And our topic for today is about control and prevention of communicable diseases. Okay, this chapter introduces principles in disease control and prevention, particularly yung mga infectious diseases, including a review of immunology, and it focuses on frameworks that can guide public health interventions in addressing communicable diseases. Specific communicable diseases are discussed in this chapter, particularly yung common sa Pilipinas. Okay? Control and prevention of communicable diseases. Okay, we have two categories of disease. We have communicable. Ibig sabihin, the disease is transmittable. Okay, it can spread to one person to another. The non-communicable diseases naman is a non-transmissible siya, no? So, it does not infect other person, no? So, again, communicable, transmittable. And the second one is the non-communicable disease, which is non-transmissible. Communicable diseases are caused by microorganisms, which can either be not bacteria, parasite, fungi, we have the prion or the virus. Okay. Saglit lang ipa-enter na tong uban. Admit na ba? Okay. And the concept of disease causation is explained in germ theory. Okay, and this is the explanation or the statement. Okay, from germ theory. No? It explains that the growth and reproduction of a microorganism inside a human body can cause a specific disease. And a disease causing microorganism is called the pathogens. Okay, it could either be the bacteria, parasite, yung fungi, you have the virus, or the prion, no? Or the prion. Okay, so a person can be exposed to many microorganisms, but it does not necessarily mean that the person will get sick and will develop that kind of disease, no? So if a person's susceptibility to the disease added with the pathogenicity of the development of microorganism inside the body can increase the risk of having a disease. So, the human body is equipped to defend itself from these pathogens. This defense is referred to as the immune system. So immune system is the defense system of the human body. And there are two types of immune system. We have the innate immune system. And we have the adaptive immune system, or it's also called as acquired immune system. Innate immune system is a non-specific, does not confer a long-term immunity against pathogen, and it is a generalized immunity that all human are born with, no? Gikan pa lang siya since birth, nanana siya ninyo ha. So, meaning to say, this is the first line of your defense, no? First line of your defense system, ang innate immune system. And number two, we have the adaptive immune system, which is actually acquired, no? And this is acquired immune system. It's highly specific, which involves specialized immune cells and antibodies that attack foreign invaders and create a long-term memory against pathogens. Later on, I'll show you a table, a comparison between the two, no, of different parameters. You have the functions of an innate immune system. Number one, recruiting of cells to the site of infection through the production of chemical factors, including specialized chemical mediators called cytokines. These are specialized chemical mediators, cytokines. Number two, activation of complement cascade to identify bacteria, activate cells, and promote clearance of antibody complexes. Okay, these are the receptors, guys, no? Okay, if you remember the key and lock theory, in order for the receptor or in order for the body to identify a certain foreign substance, no, nag-enter sa tong lawas, then we have this receptor, no, na siya mag-identify. But in this case, these are what we call the B and T cells, no? The third one is the identification and removal of foreign substances present in organs, tissues, and blood, and lymph by specialized white blood cells. The fourth function of your innate immune system is the activation of the adaptive immune system through a process known as antigen antibody generator presentation. Antigen is defined as any substance that binds to specific antibody and elicits an adaptive immune response. Antigen, guys, is very important in order for our immune system to stimulate. No? And these are foreign substances actually. Okay, these are foreign substances that gets in the body. Now once nga ma-identify siya sa B cells, and that's the time nga ma-stimulate the immune system through our T cells, no? And our line of defense, the first one is our, what we call the innate immune system. Okay? Pag ni-invade sa antigen or pathogen, ang innate immune system, this is a time that the acquired immune system takes over, no? Nana. Number five, we have the acting as physical and chemical barrier to infectious agents. Later on, you will understand that this all, no? Ito mga physical barriers na to. So the innate immune system is the first line of defense and contains, let me just correct this one, no? This is first line of defense and contains anatomical barriers that prevent the entry of microorganisms, okay? And these are our follow. We have the eyes, is one of the barriers. These are physical barriers, guys, no? We have the GI tract or the gastrointestinal tract, the nasopharynx, we have the respiratory tract, and the skin, okay? The first reaction of the body as a response of a pathogen or antigen is inflammation. And inflammation is characterized by the following condition and is considered to be the classic signs of inflammation. Number one classic sign of a person having an inflammation is erythema or redness of the skin, which is termed as rubor. Okay, increased local heat temperature or calor. Third is localized or generalized pain, which is dolor. And we have the last one, swelling of the tissue, which is termed as tumor. Inflammation is brought about the reactions of what we call macrophages. No, it's a type of white blood cell that surrounds and kills microorganisms. We have the dendritic cells, which is a special type of cell also, no? Or it is also called an immune cell that is found in your tissues, skin, or it also boosts immune responses by showing antigens on its surface to other cells of the immune system. We also have your histiocytes. It's a morphological term referring to a tissue resident macrophages. And the last one is your mastocytes. On the surface of these cells, guys, are receptors, and they are called pattern recognition receptors, which recognize certain common molecules present in all pathogens but not present in the host cells. Okay, so meaning these are actually proteins capable of recognizing the specific molecular structure of on the surface of pathogen or pathogens. White blood cells and leukocytes are the cells involved in the innate system, and the types of leukocytes or white blood cells, no, and their functions are stated below. We have your leukocytes here: neutrophil, dendritic cell, basophil, eosinophil, mast cell, macrophage, and natural killer cell. For neutrophil, it's the most abundant form of phagocyte, the first to go to the site of inflammation or infection. So, say this phagocytic, no? Ang neutrophil is phagocytic. Siya ang una mo sugod, no? Mura siya soldier, no? Nakauna. We have number two here, dendritic cell. It's mostly present in tissues that are exposed in external environments such as the skin and mucosa. And it serves as the link between the innate and adaptive immune system. Number three, we have your basophil. It releases histamine in response to a parasitic infection. Okay, if there is a parasitic infection, then automatically histamine is released by basophil. You have the eosinophil, releases toxic molecules in response to a bacterial or parasitic infection. No? Still, again, eosinophil and basophil, pag parasitic infection, sila mo so good, do, and may damage tissues. Mast cell releases heparin, histamines, chemokines, chemotaxic, cytokines involved in allergic reactions or anaphylaxis and wound healing. No, that's your mast cell. Mast cell is also called mastocyte. No, So it's actually large connective tissue that contains histamine, heparin, and serotonin, which are released, guys, when you have an allergy, okay, by some classic signs like allergic reactions or in response to injury or inflammation. We have your macrophage. It's a phagocytic cells which can move across the walls of capillary. Now, phagocytic, meaning it engulf, no? Engulf sila og mga invaders. So the neutrophil, dendritic, and macrophage are phagocytic cells. You have natural killer cell destroys compromised host cells such as the virus infected cells or even tumor cells. So those are your white blood cells, okay, types of white blood cells and their respective functions. When a pathogen is able to evade the innate immune system, the adaptive immune system takes over, as I mentioned. No? And there are three major functions of adaptive immune system. Number one, we have recognition of specific non-self antigens in the process of self during the process of antigen presentation. Second, the generation of responses that are tailored to maximally eliminate specific pathogen infected cells. And lastly, development of immunological memory in which pathogens are remembered through B cells and memory T cells. Similar to the innate immune system, the adaptive immune system also has humoral and cell mediate immunity components. Okay. Guys, can you just please turn the page to 57? No, na drawing diya kanang components of immune system. Let me show to you. We have the innate system, innate immunity, and there are three barriers no para maprotektahan ta. We have the physical barriers, we have the cellular barriers, and the chemical barriers. For the physical barriers, it includes skin, mucous membranes, and yeah, skin and mucous membranes. And for the cellular, we have PMNS, we have the monocytes, macrophages, and eosinophils. These are phagocytic cells. And for the chemical barriers, we have the lipids, your your pH, and your enzymes. Okay, and your acquired immunity. The components of your acquired immunity are your antibodies, humoral B cells, lymphokines, T cells, and your cellular. No? The antibodies is actually produced by your B cells. Okay, moving on. Cells involved in adaptive immune systems are lymphocytes, and the types of adaptive immune system and their functions are as follow. Now, we have the T helper cell, the cytotoxic T cell, memory T cell, suppressor T cell, and your natural killer T cells. Okay, so T helper cell, also known as the CD4 plus T cells, it secretes cytokines, assists in the maturation of your B cells, and activates cytotoxic T cells and your macrophages. Okay, CD means that's cluster of differentiation 4. No, meron din tayong tinatawag na CD8, that's cluster of differentiation 8. No? So first cytotoxic T cell, it's also known as CD8 plus T cells. It destroys virus infected cells. You also have your memory T cell here that gets activated upon a re-exposure of your antigen, no? And it can either be CD4 or CD8 plus. On the other hand, your suppressor T cell shuts down T cell mediated immunity toward the end of an immune reaction. And lastly, you have the natural killer T cells that produces cytokines and cytolytic, which are actually cell destroying molecules. Okay. B lymphocytes are predominant cells involved in the creation of your Ig or your immunoglobulins. Okay, it's also called as antibodies. No? The production of your antibodies is a process that is occurring is a process occurring in a humoral immunity response, and there are five immunoglobulins, and they are the IgG, IgA, IgM, IgE, and IgD. Ig stands for immunoglobulin or immunoglobulins. No? Okay, that is the structure of your IgG, Mashagway. And its description is the majority of antibody-based immunity against invading pathogens and the only antibody capable of crossing the placenta to give passive immunity to the fetus. No? So since you were born, since napa mo sa inyong sa tummy sa inyong mom or sa inyong mother, no? Kanilang siya ang immunoglobulin nga gapa sa placenta, no? Nga gahatag sa inyo og strength kay if baby pa lang mo wala ga develop nga immunoglobulin sa inyo, instead kanila gyud ang IgG. And then dili ba na siya magdugay, guys? Mo nang kinahanglan acquired nga mga immunities, no? Because it's an innate immunity, and innate immunity system dili siya magdugay sa lawas nato. So it takes time before it will expire. Then after that one, nanapoy gitawag na tong acquired immunity. Though ang adaptive is always our first line of defense. Naagyapon siya diha until mo dako ta, no? Pero sa baby mo wala siya unless matagaan ang baby or another vaccine, no? For him or her to be protected from other pathogens. We have the IgA that's found in mucosal areas such as the gut, respiratory tract, and urogenital tract. Saliva, tears, and breast milk prevents colonization of pathogens. You have the IgM eliminates pathogens in the early stages of B-cell mediated immunity before there is sufficient. IgE binds to allergens and triggered histamine release from mast cells or mastocyte and basophils and is involved in allergy, also protects against parasitic worms. And we also have functions mainly as antigen, IgD, which functions mainly as antigen receptor and B cells, and that have not been exposed to antigens. Okay, all of this, few of this immunoglobulins, you will actually see this product, no? Pag nalama sa hospital, and when you become a hospital pharmacist, may encounter ninyo siya ng mga products. That's why the adaptive immunity system or the adaptive immunity or acquired immunity is very specific, highly specific, because kabalo man taon siya nangawala sa tuwang ang pwede nato ibutang pod i-inject, no? You're very specific about it, like the IgA, mga IgE. If we need to be protected from this kind of pathogen, then this immunoglobulin is the perfect element, no, na pwede nato magamit to protect us from that pathogen. Okay, a critical difference between T cells and B cells is that the T cells recognize their cognate antigen in a processed form, like as a peptide in the context of MHC. MHC stands for major histocompatibility complex, whereas B cells recognize antigens in their native form. Once B cell encounters its antigen and receives an additional signal from T helper T cells, it further differentiates into an effector cell, and that is also known as a plasma cells. And plasma cells, guys, are short-lived cells, and it took them 2 to 3 days na mamatay siya, and that secretes antibodies. No? After siya mamatay, mag-secrete din siya antibodies. So that's it. Immunological memory can be in the form of either passive or short or active or long-term memory. And immunization is a process whereby person is aid. Sorry, it's made, no? It's made na siya. Okay, immunization is a process whereby a person is made immune or resistant to an infectious disease, typically by the administration of vaccine. Vaccines stimulate the body's own immune system to protect the person against subsequent infection or disease. The principle behind immunization is to introduce an antigen derived from a disease-causing organism that stimulates the immune system to develop protective immunity against the organism, but that does not itself cause the pathogenic effects of the organism. A vaccine, depending on its type, can provide either passive or active immunity. Later on, I'm gonna show to you the different types of vaccine. They are actually categorized into two. No, we will find out which one long lasts or which one has short duration. No, madali siya mawala. That's why we need to give a person, no, na maging mga condition nga we need the person to he or she needs to be immunized 3 times or in multiple doses compared to the other one which we just use 1 dose lang, no, then strong na dahil kusog na iyahang dose. So may buka na tana dire. Okay, there are 2 basic types of vaccines here. Number 1, we have a live attenuated vaccines and inactivated vaccines. You will encounter the products, guys, again pag nag-work mo sa mga dagko nga mga community pharmacy na like the farm for like Mercury Drugstore, gabaligya sila manginani, pati ang Rose Pharmacy. And these are prescription medications. No? Live attenuated vaccines are produced by modifying a disease, producing wild virus or bacterium in the laboratory. And we have the second type of vaccine. We have the inactivated vaccines. Vaccines consisting of virus particles, no? Katong mga virion. And other pathogens and that have been grown in culture, gina-culture siya, and then ginapatay po siya, killed to destroy disease producing capacity. This can be composed of either whole viruses, bacteria, or fractions of either. So this is the method of live attenuated vaccines, no? Number 1, wild viruses, bacteria, attenuated meaning to say they are weakened. Now these are viruses that are weakened due to the repeated passing in cell cultures, no? Pero dili siya gakamatay, no? And the one of our tool for the experimentation is the chick embryo, no? That's why mga more than 10 years ang mutation and weakening anemia. That's why guys, kato ito ang atong ginatawag nga H1N1 nga vaccine, kato sila nga mga vaccine. That's why ang uban dili sila gusto magpa-vaccine adto ba kay syempre a vaccine a what do you call that one? Ang vaccine kakahita mo siya, it can actually be produced, no? Completely produced like mga 5 to 10 years. Kaya siya kanang safe siya gamiton. That's why some people don't want to be vaccinated because of that reason. Nga dili sila safe o doubtful sila sa vaccine kay unsay may tabo sila. Kay it takes time for the vaccine to be completely there is actually a term for that one. Anyway, kung sa Bisaya pa ka ng tawag kalimot ko. Anyway, so it takes time for the vaccine, no? Nga mahimo gyud siyang vaccine gyud nga na-produce na gyud siya, no? 5 to 10 years. No, that's the maximum. I think is 10 years. And the tool for the experimentation used here is the chick embryo. And number two, we have the transformation of wild virus into a vaccine virus na after it's being weakened. So, nanatakaroy live weakened vaccines or live attenuated vaccines. Okay? Depende sa pathogens guys nga magamit. That's why we should be able to know first prior to producing a vaccine. We should be able to know first or be aware of what pathogen no ang nag-cause sa disease, no, para kabalo pud ta unsa nga bacteria ang atong gamiton to produce a vaccine. Okay, number three, injection of small dose of vaccine virus or bacteria, so this vaccination. Then replication of vaccine virus or bacteria in the host, a specific immune response, and the induction of an immune response, and lastly, protection against real infection. So that's your live attenuated vaccines. Okay, these are actually the comparison of your inactivated and live attenuated vaccines. Okay, guys, for the inactivated vaccines, we're actually using live bacteria or virus here. But then ginapatay lang na siya no prior to induction. While the live attenuated vaccines, kani siya gagamit kita specific bacteria or pathogen, no? Then weekend na to siya. Ato siya lang ginapahina, no? Kay according to the research, pag live bacteria sila or viruses and they are strong viruses, they may add on to the disease when it's being induced to you, no? Kanan siya. So, dapat i-weaken din ninyo ang mga bacteria or the pathogen that causes the disease. So, we have the feature here. These are parameters or feature. Now, we have the dose, efficacy, number of doses, shelf life, the safety, stability, need for adjuvant, reversal of virulence or virulence, and duration of immunity antibody response. Okay, for inactivated vaccine, the dose is high, and the live attenuated vaccine, the dose is low. Okay, because in live attenuated vaccine, the dose itself is strong already. Now that's why they give low doses. Inactivated vaccine, they give high, but in a multiple dose. No, efficacy, poor effects last a short time. While the live attenuated vaccines, it has a good effect and it lasts a long time. We also have here the number of doses used. No, sometimes ang inactivated vaccine, guys, for first vaccination for inactivated vaccine, dili pa siya mag-activate, no? Dili pa siya panglaban sa pathogen. Okay, the second and the third vaccination, kana na siya ang sa second start na siya preparation, no? Preparation niya. Then for the third vaccination, kana siya gitawag nga protection na. For the live attenuated, single dose lang, protected na ka. Okay? Shelf life is long. Okay, we're talking about the product here, and shelf life for live attenuated vaccine is short. Okay, for inactivated vaccine, its safety is good. No, for the live attenuated vaccine is poor. Okay, and the stability of the inactivated vaccine is high while the live is low. Need for adjuvant, yes. The other one, no. Reversal of virulence, no. And maybe for the other, for the live. And the duration of immunity is less. And the duration of immunity for live attenuated vaccine is many years, no. And the antibody response for inactivated vaccine is IgA and IgG, and for the live attenuated vaccine, we have the IgG. Examples of live attenuated vaccines against the viral infections are the oral polio vaccine, yellow fever, cowpox, measles. We have the smallpox, rotavirus, rubella, varicella, and the influenza intranasal form. We have the live attenuated bacterial vaccines, which include the BCG, tuberculosis, and oral typhoid vaccine. Inactivated vaccines are produced by growing the bacterium or virus in culture media, then inactivating it with heat or chemicals, and the chemicals usually are is formalin. Okay, we also have here under the inactivated vaccines are the fraction vaccine protein, fraction vaccine, no? Okay, inactivated vaccine. We also have either fraction vaccine. Sorry, fraction vaccine. It could either be a protein base or polysaccharide base. Then, kalimutan na ako niya. Okay. Okay, I'll repeat it, guys. No? Another type of vaccine that's under inactivated vaccine is a fraction vaccine. And it could either be produced either protein-based or polysaccharide-based. Okay? For protein-based vaccines, it includes toxoid, okay, which is an inactivated bacterial toxin. Usually, ang toxoid ginagamit siya, guys, no? Sa diphtheria toxoid, napunta yun sa mga tetanus toxoid, no? Pag napaakag iro, in combination yun siya always sa anti-rabies and then toxoid, always, no? And subunit of Savirion products, no? That's your toxoid. And polysaccharide-based vaccines are composed of pure cell wall polysaccharide obtained from the bacteria. And the conjugate polysaccharide vaccines contain polysaccharide that is chemically linked to a protein. And that's the reason why your polysaccharide is more potent vaccine compared to others. Okay? So the available whole viral inactivated vaccines are as follow. We have the polio, hepatitis A, rabies, and influenza vaccine. Okay? Okay, basi ma-confuse mo guys ha. Napapunta example there is a live attenuated, no? So this one is oral polio vaccine for the live attenuated, but for inactivated we also have polio vaccine. So inactivated bacterial vaccines, we have the pertussis, typhoid, plague or plague, and lastly we have cholera. For fractional vaccines include subunits of the following, no? Include the subunits of the following. We have hepatitis B, influenza, acellular pertussis, which is the whooping cough, no? If you're familiar with that one. Human papilloma, this is papilloma virus. The anthrax and the diphtheria and the tetanus. No? And the toxoid fractional vaccines here are the diphtheria and the tetanus, as I mentioned. So these are the fractional vaccines subunits. Okay, moving on to the next page. Okay, polysaccharide vaccines are a unique type of inactivated subunit vaccine composed of long chains of sugar molecules that make up the surface capsule of certain bacteria. Pure polysaccharide vaccines are available for 4 diseases. We have the pneumococcal disease, meningococcal disease, Salmonella typhi, and the Haemophilus influenzae type B or the HIV. Vaccine antigens may also be produced by genetic engineering. No? In this way, there's a modification of the vaccines. These products are sometimes referred to as recombinant vaccines, which uses another organism or multiple of organism to make a vaccine antigen. Like for example, the example is actually shown here at page 62. No? Like for example, yung hepatitis B at saka yung human papilloma virus, they are produced by insertion of segment. When they are combined together, no? Na-try na din kasi ito, no? Sa research, during its insertion of a segment of the respective viral gene into the gene of yeast, cell, or virus. The modified yeast cell produce a pure Hepa B and another pure human papilloma virus. Okay, because ang akong nasabtan ani guys no kay kung mag-combine kag duha ka buok nga mga viruses, no, duha ka buok, mas ga-stimulate ang T cells nato, no? Pag mag-stimulate ang T cells, ang B cells pod nato gahatag pod siya og daghan antibodies, ga-release siya og or ga-produce siya daghan antibodies pag naay combination sa isa ka virus nga gibutang, no? And that is what they call recombinant vaccines. So it is very important to know the type of pathogens that is causing the disease so that we know how are going to treat the patient, no? Or to do a medical intervention. Okay, ang uban bacteria, they have different, or viruses, they have different characteristics. And if we found out that kind of characteristic, kabalot taon saon pag manage, no, sa sakit. So there's also, we have also here our a lot of causative agents here and their corresponding diseases, no, nga ga-cause sila. So this one, we have causative agent for, and this is actually a bacterial causative agent, not these are bacteria. We have Clostridium botulinum, we have botulism leptospira, that's Wales disease, which is also known as leptospirosis. Okay, the causative agent for tetanus is Clostridium tetani, and we have tuberculosis, Mycobacterium tuberculosis, Salmonella typhi. That's for typhoid fever, and the Corynebacterium diphtheria. And so on and so forth. So just please read them all, sa bacteria. And for your virus, the causative agent for rabies, we have the rabies, rhabdovirus, or rabies virus. We have the rotavirus for severe diarrhea. We have the Epstein-Barr virus, infectious mononucleosis. Guys, if there are corrections using the pencil, can you please change that one, okay? Okay, kanang pencil mo na siya ang correct na spelling. Okay, same goes with Neisseria gonorrhoeae. Paki-check ninyong spelling, no? And your gonorrhea here is the disease that's being caused with your Neisseria gonorrhoeae for bacteria nga column, no? And please read them all, daghan kayo siya. And we also have here parasite, Entamoeba histolytica, amoebiasis, Ascaris lumbricoides, Ascariasis, and we have the tapeworm infection, which is Diphilo or Phyllobothrium latum, the Ancylostoma brasiliensis. That is Brazilians, guys, ha? Can you please check that one? Okay. If you look at the table, the writing using a pencil is the correct one, no? That's the correct spelling na siya. Cutaneous larva migrans. We have the Taenius species, tapeworm infection, and cysticercosis. We also have Trichuris trichiura, no? It's for whipworm infection. Okay, the last one is a fungi. We have Candida albicans, Candidiasis, Dermatophytes, ringworm, Cryptococcus neoformans, Cryptococcosis, Triptococcosis, and the Trichophyton species, which is Athenia pedis or athlete's foot. Okay? Okay, guys, Candida albicans. Candida is actually the genus, no? And the albicans is the species. So that's how you also read that. Genus Candida and species albicans. Or Candida albicans is a species. Di man kayo sa taas. Tama raman ang topic. Masabtan man po niya. No? So now moving on to our next topic is the bacteria, no? So it's very important for us to identify what bacteria that causes the disease so that we'll be able to also understand, no? To know or to give a a appropriate medical intervention, no, to the person who have that kind of disease. So dapat may buwan na to kung bacteria ba, virus or sa ba na, fungi ba siya. Okay, because we cannot give an antifungal agent or medication to a person having a virus infection, no? Hindi na siya maayo. So, a bacterium is a prokaryotic microorganism. Okay, when you talked about uh, prokaryotic, wala siya yung mga organelles na ang ganing prokaryotic. And prokaryotic organisms are bacteria and archaea lang. No? So, these are the morphologies of the bacteria. We have rod shape. Morphologies is the shape, guys, no? Rod shape, spherical, curved, square, and star shaped. And bacteria often attach to surfaces and form dense aggregations called the biofilms. Those are your biofilms. Okay. Biofilms is also called bacterial mats. And if the bacteria as a protected biofilms are much harder to kill. We also have here another term, flagella. These are organelles used for bacterial locomotion. You're already familiar with this. It's so very basic, no? And one of the example of a microorganism which has two distinct modes of movement is the E or E. coli. Okay? E. coli use flagella in forward movement. So, pag-swim sila, muna yung ginagamit. And tumbling. Motile bacteria are attracted to certain stimuli and behaviors, and these are called the chemotaxis. So these are bacteria that goes to one direction, guys, no? Because they are attracted to chemicals, like for example only. For phototaxis, energy taxis, and magnotaxis, no? These are the different behaviors. Bacteria can be classified according to how they respond to gram staining, no? Para ma-identify nato kung unsa ba siya, positive ba siya or negative. The thick layers of peptide glycan in the gram-positive cell wall, the stain is purple. On the other hand, the gram-negative bacteria, the stain is pink. Okay? Negative, pink, positive, purple. Some organisms are best identified by stains other than the gram stain, particularly katong mga mycobacteria and nocardia, which show show acid fastness or the Ziehl-Nielsen method. No? Kana siya. Bacteriostatic infections may be treated with antibiotics, which are classified as bactericidal, which kills bacteria, no? While bacteriostatic, they prevent the growth of bacteria. Simple na kayo guys, no? Basic na kayo siya. Now, moving on, we have the virus. Virus is smaller than bacteria. Okay? It can even infect bacteria and other larger microorganisms. And there are three major components of your virus. And these are genetic material, which could either be your DNA or RNA. We have the protein code. This protects the genetic material. And lastly, we have the envelope of lipids, which surround the protein code. Okay, similar to bacteria, viruses also have various morphologies. A complete virus particle, which is termed as your virion, consists of nucleic acid surrounded by a protective coat, no, called the capsid. These are formed from identical protein subunits called the capsomeres. And viruses can have a lipid envelope derived from the host cell membrane. The capsid is made from the proteins encoded by the viral genome, and its shape serves as a basis of morphological distinction. Virally coded protein subunits will assemble to form a capsid, in general requiring the presence of the virus genome. And the complex virus code for proteins that assist in the construction of their capsid. Proteins associated with nucleic acid are known as nucleocapsid. And there are four main morphological virus types. Number one, we have the polyhedral, okay, the spherical, helical, and complex. Okay, so all of the adenovirus, no, are polyhedral in shape. The influenza is spherical. We have the tobacco mosaic virus is helical in shape, and for the complex, we have the bacteriophage. Okay. For the helical virus, it's composed of a single type of capsomere stacked around a central axis to form a helical structure. Just refer to the photos that I provided, you know. We have the icosahedral or polyhedral viruses that compose of 20 phases, just like the polyhedron. And the minimum number of identical capsomeres required is 12, each composed of 5 identical subunits. Many viruses, such as a rotavirus, have more than 12 capsomeres and appear spherical, but they retain this symmetry. Capsomeres at the apices are surrounded by 5 other capsomeres, and they are called pentrons. Okay, every segments of 5 capsomeres is called pentrons. No? Pentons, sorry. Okay, spherical viruses are ball shaped. They are also referred to as envelope viruses. The most well-known examples of envelope viruses are the influenza virus, hepatitis C, and the HIV. Okay, the last main morphological virus type is your complex virus or viruses that have a combination of icosahedral and helical shape, and they have a complex outer wall or head tail morphology. The head tail morphology structure is unique to viruses that only infect bacteria and are known as bacteriophages. One of the most famous types of pox of this one of the most famous wait, nawala ko guys, sorry. Okay, the bacteriophage uses its tail to attach the bacterium, creates a hole in the cell wall, and then inserts its DNA into the cell using the tail as a channel. The pox virus is one of the largest viruses in size and has complex structure with a unique outer wall and capsid. And one of the most famous types of pox virus is the variola virus, which causes smallpox. So, I mean to say, variola virus is is one of the example of your complex virus also. Okay, I will read this one to you guys now during the pandemic. Importante ba niya siya? Oh. Virus undergo frequent mutations or change. So in their genetic component, thus it can sometimes be very difficult to destroy a particular virus. Virus undergo genetic change by several mechanisms. This includes a process called antigenic drift, where individual bases in the DNA or RNA mutate to other bases. And most of these mutations are silent. They do not change the protein the genes encodes, but others can confirm evolutionary advantages as such as resistance to antiviral drugs. Okay, so meaning to say virus undergo frequent mutations, and as they mutate, guys, no, using different kinds of mechanism, they don't just change their proteins and their other cellular components, no, cellular components. They don't even change their gene encodes, but katong resistant sila sa antiviral nga mga medications. So the more nga mutate sila, the more nga resistant sila sa mga antiviral medications. And antigenic shift, di din siya drift, no? Mali, hindi siya cold drift. Okay, antigenic shift occurs when there is a major change in the genome of the virus. Okay, kanina is drift to siya, guys, no? Karon antigenic shift occurs when there is a major change in the genome of the virus. This can be a result of recombination or reassortment. When this happens with influenza virus, pandemics might result. So a recombinant or a combination with other viruses, no? Mutate siya. So that's antigenic shift. So viruses do not reproduce through cell division because they do not have cellular components. Okay? Instead, they use the machinery and metabolism of a host cell to produce multiple copies of themselves, and they assemble in the cell. This process has two following steps. You have attachment, penetration, and replication, and release. I just want to correct a while ago, guys, no? Protein data siya, dili siya cellular components, no? Ang mag-change siya because the fact that the virus does not have cellular components, so there's nothing to change except for the protein. Okay, these are the steps, no? Attachment, specific binding between viral capsid proteins and specific receptors on a host cell surface. We have penetration, virions, which is a complete virus particle, as I mentioned, enter the host cell through receptor-mediated endocytosis or membrane fusion. We have replication. No? It involves a multiplication of the genome and release. The viruses can be released from the host cell by lysis. It's a process that kills a cell by bursting its membranes. So some viruses undergo lysogenic cycle where the viral genome is incorporated by genetic recombination into a specific place in the host chromosome. The viral genome is then known as provirus, or in the case of bacteriophages, a prophage. Envelope viruses, example is that your HIV typically are released from the host cell by budding, and during this process, the virus acquires its envelope. Okay, you also have your parasites here. Okay, next pathogen is your parasites. Your parasites are also called non-mutal symbiotic. Okay. Parasites are called as such due to their non-mutal symbiotic relationship with their host. Parasites typically do not kill their host and are generally much smaller than the host, and will often live in or on their host for an extended period of time. And there are three main classes of parasites that can cause human diseases. We have the protozoa, helminthids, and ectoparasites. Okay, another pathogen here is your protozoa. Protozoa. These are microscopic one-celled organisms that can infect and multiply in human beings. Protozoa are abundant in aqueous environment and soil, occupying a range of trophic levels. The group includes flagellates, which move with the help of whip-like structures called flagella, and ciliates, which move by using hair-like structure called cilia. Okay. Again, flagellates, they use their Okay, flagellates, which move with the help of whip-like structures called the flagella, and your ciliates uses their hair-like structures to move, no, and these are called your cilia. And the protozoa are classified into four groups according to their mode of movement. We have the Sacardina. Okay, the example is amoeba. That's Amoeba, pero pwede din amoeba. I saw this spelling too. Now also have Mastigophora, also known as the flagellates, and the Ciliophora, ciliates, and the Sporozoa, Plasmodium, and Cryptosporidium are its examples. No? Next is your helminths. Helminths are large multicellular organisms that are generally visible to the naked eye. No? Ito mga uod. Like protozoa, helminths can be either free-living or parasitic in nature. In their adult form, helminths cannot multiply in humans. There are three main groups of helminths that are human parasites. We have the flatworms, acanthocephalines, and we have the roundworms. Another term for flatworms is platyhelminths. It includes nematodes and your cestodes. Acanthocephalines are also referred to as thorny-headed worms. And the roundworms, which is very popular, no? Sa mga kids nga nasa squatter area, ang cute mo niya siya. It's very evident if you visit them there. It's tapos nagpa-purga ka with animal roundworms. Okay? The adult form of these worms can reside in the gastrointestinal tract, blood lymphatic system, or subcutaneous tissues. Alternatively, the immature larvae or larval states can cause disease through their infection of various body tissues. Okay, some consider the helminths to also include the segmented worms or the annelids. The only ones important medically are the leeches. Okay, all of these are typically called parasites. An infection by the helminth is known as helminthiasis, a soil-transmitted helminthiasis, or helminth infection, or intestinal worm infection. So these are the infections, no, caused by helminth. Helminths are worm-like organism living in and feeding on living hosts, receiving nourishment and protection while disrupting their host nutrient absorption, causing weakness and disease. Again, they don't kill their host. Okay? In the life cycle of a helminth, there are at least three stages. We have the egg stage, larvae stage, and adult stage. Okay, in egg stage, all helminths produce ova or eggs. Each egg has a hard, protective three-layered shell. This protects the eggs from external environment, and this makes the eggs viable for months even while on the soil. For larvae stage, the larvae can hatch from the eggs, whether outside or inside the host body. The larvae will then mature into adult worms within 1 to 2 months, depending on the type of the helminth. Okay, for adult stage, adult worms can either have differentiated sexes or can be hermaphrodite. Adult worms can then produce eggs which can be secreted out of the host, deposited into the environment, and can pick up by another host. Okay? Okay, lastly, we have the ectoparasites here. It's one of your pathogens, no? Although the term ectoparasites can be broadly include blood-sucking arthropods such as mosquitoes because they are dependent on the blood meal from human hosts for their survival. This term is generally used more narrowly to refer to organisms such as ticks, fleas, lice, and mites that attach to burrow into the skin and remain there for a relatively long period of time. So, compared to the mosquitoes, no, once they bite you, they move away, they go away. So it's different from the ectoparasites such as the tick, fleas, lice, and mice. They actually stay for a long period of time sa imong skin. And the source of meal is your blood. Arthropods are important in causing disease in their own right, but are even more important as vectors or transmitters of many different pathogens that in turn cause tremendous morbidity and mortality from the disease they cause. Okay? They're also vectors, guys, no? Because they are carrying pathogens, no? And once they bite us, then they cause the disease. So sila ang medium, no, mode of transmission. So that's your ecto parasites. Okay, what's the implication in public health? It is important to categorize a type of communicable diseases. Important type of communicable diseases. One basis of categorization is the duration of the disease. A disease can be acute if it's lasts less than 3 months. If it's chronic, that's more than 3 months. If the disease is 3 months, more than 3 months, and it becomes chronic. But pag ang disease is less than 3 months, that is considered acute. Okay, non-communicable diseases can also be classified such as such, no? Could be chronic or acute. Okay, a person who has or suspected of having an infection is referred to as a case. In public health, cases of particular disease are counted and monitored and reported, especially if they are notifiable disease. An infection is transmitted from one person to another in different ways. Number one, we have direct contact transmission. Okay, for direct contact transmission, the spread of infectious organism from the skin of one person directly to another person. So direct contact transmission. Okay, that's through your skin pores, no? Indirect contact transmission, spread of infection organism by coming into contact with a contaminated object and then bringing the germ into your body. So it's used an object now. The object could be sa skin too, no? Or anything that you hold from which it is already contaminated by specific pathogen. You have the airborne transmission, spread of infectious organism through the air. These germs can survive in the air for long periods of time and travel far distances from the infected person. We also have the blood-borne transmission, spread of infectious organism through direct blood-to-blood contact. Droplet transmission, spread of infectious organism from an infected person in tiny droplets. Katong musingab ay mo atching bitaw. Hindi mo makita siya sa your naked eye, pero na yung masina na nga makakita ang paglupad sa atong droplets ba. And lastly, we have a sexual contact transmission, spread of infectious agents from an infected person to another person through sexual contact. So the ineffectivity or the ability of the organism to enter and replicate in the host depends on three major factors. One, the nature of organism or agent or pathogen, the nature of the host, and lastly, we have the environment. So these are the three major factors. Okay, of the host, no? To develop and replicate, kung dili man ineffective siya once it's being in your system. No? So major factoring agent, ang pathogen, o the agent or pathogen, the host, and environment. Okay, the environment, maybe because kung hugaw kayo environment, no? Pwede siya cause of disease. Pwede mag-develop ang mga pathogens, no? Within your environment. Okay, pwede ka magkasakit because of your environment. But if your environment is clean, then most probably you are away from those diseases. So pag ang host pod malusog, no, host is able to respond to such diseases or causative agents, no, nag-cause a disease, then pwede po siya resistant, no, nga sakit. Pag ang host pod ang iyang immune system hina, so there's a time na pwede siya maapektuhan. And same goes with a pathogen. Depends sa pathogen na pwede maka-affect sa mga. Okay? So, tama na siguro dili ang arthropods. These are major disease vectors. Please read them all, no? Ang sa arthropods, the examples of this are mosquitoes, flies, lice, ticks, and mites. I mentioned it already sa previous stage. So guys, please also read number 76, no? Page 77, 78, and 79. Okay? Um, okay. Can you also please read examples of vector-borne diseases that is common in the Philippines? We have dengue, malaria, chikungunya, lymphatic filariasis, Japanese encephalitis, and the schistosomiasis, no? And the vectors, no? Ang mga carrier ba, no? These are the carrier, the vectors, and the causative agent of such diseases. Like for example, the dengue virus, that's actually a flavivirus, and it causes a dengue. And another one is a chikungunya virus. Okay, that's for chikungunya nga disease. Okay, Schistosoma species, Schistosomiasis. So please read them all. Until lang ta sa goals of epidemiology, no? So please read them all. And different approaches, no? In communicable diseases, we have the primary, secondary, and tertiary approach. And that's it. You also have here a term, no? Isolation and quarantine. So take note of that one. Okay, take note of this one, guys. It's very important in public health that the only disease that has been eradicated. Okay, meaning to say, total elimination of disease in the community is the chickenpox. The smallpox. No, so that's a communicable disease that has been eradicated. So wala na kayo yung smallpox, no? So kami sa disease na-eradicate na sa community. So let's also read that. And what else? I think that's all, no? So please study chapter 4 and 5 until the different approaches, no? Approaches of the management or prevention and control of communicable diseases, which includes the primary prevention. We have the secondary prevention. And it's different approach, no, under the umbrella of secondary preventive measures. And we also have tertiary preventive measures. So it includes the convalescence from infection, recovery to full health, and return to normal activity. So that's your tertiary preventive approach. Okay. Kindly study chapter 4 and 5 until the different approaches in the management or prevention control of communicable diseases. Okay, tuberculosis, sa next na, sa semifinals na. No? Different kinds of diseases that are common in the Philippines and our medical and the appropriate medical intervention application. That's it. Okay, any question? Ang atong public health, Thursday pa ang exam, ha? Normandy, wala na? Chavez, Ignacio, Hapay.
Wala na, sir.
None, sir.
Okay. Guys, basahan lang niyo. Dali man masabda ng vaccines. I mean, the topic for chapter 5 is very basic yun siya. No? You already aware of this. We knew this. We knew them, no? The different terms. Since atong gikuha ang microbiology, and you encounter this from other subjects too. So it's very easy to understand, and basahon lang gid ninyo, dali ra gid kay ang topic, no? Dili kay lisod. Okay? Wala na question, okay na ta? Okay. Class, thank you for coming to the class today. Wala pa ko nakabalo kaya ang exam nga ako naibaw antong ako gisultian lang ko, exam sa cosmetic, wa pa ko sa cosmetic. Public health ako naibawan gi Thursday nila. Gi Thursday ni Ma'am Loy, no? So kato siya. Kaya pala ako naibawan ang sa kuha. Exam lang sa cosmetic pharmacy. Okay. Guys, for the cosmetic pharmacy, I'm going to post the slides also, no? Sa next na to nga topic, that's part of your semifinal. So duha ka book na topic inyo ang cosmetic pharmacy. Okay? So that's it. Okay. Thank you for coming to the class today. Appreciate your time and hope to see you guys tomorrow. Ba natin class tomorrow? No. We don't have class tomorrow. No? See you tomorrow and God bless. See you next week during your exam and good luck, no? Thank you and bye-bye.
Thank you, sir. Goodbye.
Thank you, sir. God bless.
Sir.
Thank you, sir.